Hello guys. So as we are moving towards the basics of stereochemistry, and we have learned so many things in the previous videos with R and S configuration. After that, I will also introduce this term Erythros and Threos system of nomenclature, in which we will say something like D and L configuration, R and S configuration. Similarly, Erythro and Threo system of nomenclatures is important to learn, where it is not being used so much, but you should know what is the difference between erythros and threos. So, if you will see this picture, I'm just from this, I'll check this. If you will see from the previous picture, these OH and two OH bonds are on the same side. So, and hydrogens that is of blue color are on the same side. They are called erythros. And when they are on a opposite side, we are saying they are threos. So, let's talk about something. So, what the students will learn about? First of all, students, they should know historical origin of erythros and threos nomenclature in stereochemistry. And also the students, they will understand the specific condition under which erythros and threos nomenclature are equal and are being employed to particularly in text of diastereomers. And student will also learn how to identify erythros and threos isomers in a molecule, especially in compounds with two adjacent stereo centers. Means there are two stereo centers, more than one stereo centers are there. And students, they can compare like erythros and threo nomenclature with another nomenclature like R and S, cis and trans, so that they can also get to know that what is the use of erythros and threos. Now, after completing this video, you will learn that how erythros and threo nomenclature, they are exist, and they describe the distinguished properties between the diastereomers in the organic chemistry. Now, let's talk about first erythros and threos. So this is the erythros, where erythro is a diastereomer and threo diastereomer. So this is the why we call it is erythro, because here OH are on the same side, but here OH are on the different side. So this is an old-fashioned, basically erythro-threo nomenclature, but indicates that diastereomeric relationship between two compounds with adjacent stereocenters. And what does it mean basically? So erythros and threos, they are the four carbon aldose. Okay, where aldose is aldehyde ketone, aldehyde group is there. It's a aldose. So here same you can see check aldose. So in this we are saying that they are four carbon aldose and they are diastereomers. In erythros, basically, in erythros, oxygen are oriented on the same side in the Fisher projection. Okay, and in the threos, they are oriented in the transform. And erythros and threo prefixes, they generalize the relationship between the other diastereomer, basically. So, the other molecules with two different stereogenic centers, not necessarily that they can be on adjacent, are frequently designated by the prefix threos and erythros. They are interpreted as meaning that two identical any groups, similar groups are on the same side or on the opposite side. If they are on the same side, we will say they are erythros, and if they are on the opposite side, we call them they are threos. Okay, so where in a Fisher projection. Okay, so the names derive from the saccharide erythros, and they are erythros and threos. They are saccharides. So if you will draw the Fisher projection, here you can see this OH and this OH are on the same side. This OH and this OH on the opposite side. So that's why they are erythros and they are threos. So when we see at the two common substituents, whether it's H or OH, on the stereogenic center or on the same side or like this, then we get to know what is threos and erythros. So both threo and erythro, they exist in two enantiomeric form, which can be designated by B and L. Why is it so? Here, there is a separate, you can say, DL-N notation. There is another video I will, I have already uploaded. You can check what are D and L notation in the carbohydrates. So here, today in this topic, we just name the threo and erythros, which are applicable to both enantiomers. Here, why it is erythros? Because here OH are on the same side, these are on the same side. When you are going to put this on this, so they are not going to superimpose. So if they are not going to superimpose, so they will be enantiomers. Similarly, OH on the different side, here H on the different side, means diagonal and opposite side. And when you are going to put this structure on this, so they are not, you can say, not superimposable on each other. That's why they are called enantiomers. So B and L enantiomers, we can see these dextrorotatory and levorotatory basically. Okay, so basically the configuration of the molecule with two stereogenic center that we have already told in this example, we can take about the chlorine. It is erythros and here it is threos. And in Sahor's, if you will see here, this is the front carbon, this is the back carbon. Okay, so this front carbon can be chlorine, and this is Sahor's projection, this is Fischer projection. Here it can be act as like this. So chlorine, both are on the same side. So it is a erythro sign. But however, uncertainty arose when erythro and threo nomenclature was applied to the citron with only one common substituent on the neighboring chiral center. So what will happen? The more common and modern method is there right now, syn and anti. In syn and anti, what will happen? The compounds, if you will see, why they are syn? Because here, they are on the same side of the plane. On the same side, but here, CH3 and this here, CH3, the plane is different. They are same. And here, why it is anti? Because they are on the opposite side. Syn and anti terminology we often, quite used in Newman projection and additional reaction of alkene. So, in this case, if you will draw the carbon chain zigzag, then substitutes lies on the same side of the plane, then it is syn. When groups are on the opposite side, then they are in anti position. Like they are on the same plane. If it is a solid, then it is also solid. If it is away from the observer, this is also away from the, both are on the same. But in this case, one is going away and another is going similarly this or this. So we will simply say if they are on the same side of the plane, then they are syn. If the groups are on the opposite side of the plane, then they are anti. Thank you guys. So in this video, we have already talked about erythros and threos terminology that you should know. Thank you and stay tuned to my other videos and must watch it. If you like it, then please comment it, subscribe my channel. Thank you.